Welcome back. So in this video, we're going to talk about graphs, comparing those graphs, but not just comparing those graphs, seeing if we are noticing a pattern in the equation itself. So we have three graphs here. Hold on, because it's going to be in order just so I can write. The graph or the equation itself is above the picture. Sorry, I'm having to scan book pages in or take pictures of the book to get these in here. But we have the equation. So this graph here is a negative 4x squared. This graph here is a 1/4 x squared. And this graph here is that parent function, right? That most simple function. Y equals x squared, or f of x equals x squared. So what are things that we noted? Well, it's asking us to order them from widest to narrowest. So if we're looking at this, the widest graph is this one by far, right? It has a wide arc to it. So this would be our widest graph. So that would be f of x equals a 1/4 x squared. That's our widest graph. And then from there, this is pretty skinny. But if I look at this one, this is wider than this one. And we could even probably do a comparison about how close we are to those 1 values. But my next one is f of x equals x squared. And then lastly, that leaves f of x equals a negative 4x squared. So that's our order from widest to narrowest. What are things we notice about the equations? So these are things that I notice. That if a is less than 0, like on this f of x equals negative 4x squared, we have that negative, it opens down. Right, so that's one thing, which means the opposite would be that if a is greater than 0, which we have 2 of, right? This is 1, and this is a positive 1/4. They're both greater than 0. They're positive numbers. They open up. And so that's the first thing. And again, if it helps, if the a value is negative, we're sad with max problems. If the a value is positive, we're happy with minimum problems. And again, you can thank my Leavenworth High Schooler for that mnemonic to help him remember. The other thing I notice, if we look here, this is our most basic shape. And the 1/4 got pretty wide, whereas the negative 4 was actually pretty skinny. And so if we were to do this with a lot more, then what you would notice is that if a is greater than 1, then it's narrow. But if a is between 0 and 1, then we are wide. Okay, and actually I should put absolute value there, because it doesn't matter if it's negative or positive. The distance from 0, if it is bigger than 1, so whole numbers, then we're narrow. If we're between 0 and 1, then we're wide. Okay, so those are just some things to notice. So that's how the a value affects our graph. So now graphing y equals ax squared plus c. So before we had only graphed y equals ax squared. So now we're going to add that plus c. So we've got two graphs here. Remember, we're creating tables. I'm going to create these tables. Remember that these x values are just x values that I choose. I tend to choose -2, 0, 1, and 2. We will talk about in I think it's the next section actually, how to easily choose these for quadratics. But I've already done that hard work for us. So when I plug in, which one am I doing here? We're going to do y equals 2x squared here. And y equals 2x squared plus 3 over here. So square first. So negative 2 squared is 4 times 2 is 8. Negative 1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. So again, we have that repeat going, right? So this is my vertex. Vertex. All right, so then over here, we're starting off the same. So negative 2 squared is 4 times 2 is 8, but now I add 3. So now it's 11. And negative 1 squared is 1 times 2 is 2 plus 3 is 5. 0 squared is 0 times 2 is 0 plus 3 is 3. And then again, if you haven't noticed, we're just adding 3 down, but this should repeat if we've done it right anyway. Don't always assume that, because if you're just choosing your own x values, you may not have the vertex be your middle one. So you've got to be careful with that. I do believe for what we're doing here, our vertex is always at 0 for what we're working with. On 9.1, not the whole chapter, just 9.1. All right, so I plug in 1, I'm going to end up with 5. I plug in 2, I get 11. So here are my 2 graphs. I'm going to graph them. We are going to do it on the one that's here. These 11s, I'm just going to take them slightly off. I'm going to pause to make these graphs because we don't need to make this video go even longer, and then we'll come back and talk. All right, I will admit these are not pretty parabolas. This was me trying to like make it more of a U shape and less of a whoop, totally missed the points. And so we get a little hairy here. But as we look at these, what I notice, our widths didn't change, right? This A value is the same for both. So there's no change in my width. What happened to my graph is that and what happened to our table, right? Our table increased by 3. What happened to our graph? We shifted up by 3, right? So if we look at what we notice about this, what is the difference? 2x cubed plus 3, how is that different from y equals 2x squared? Y equals 2x squared plus 3 shifts the graph up up 3. So if plus 3 shifts our graph up, what, and I'm going to leave it out there, what do you think 2x squared minus 3 would do? Okay, I'm leaving that to you. I am going to move on to this next one, last one. Word problem comes down to this. It wants to know the graph of the function and about what time does the acorn hit the ground. It gives you the equation. Okay, you don't have to know your equation quite yet. It gives you your equation. So we're just going to create our table of values. I'm coming up with the values. Actually, the book came up with the values and I'm using them. So 0, 0.5, 1, and 1.5. Okay, and so then I plug in 0 into this equation. You can use your calculator, and when I plug this in, I get 20. Notice that's what C is. So when we plug in 0, we're left with C. C was going to be our y-intercept. I didn't mention that in the last one. We plug in a half, and we end up with 16. We plug in 1, and we end up with 4. And we plug in 1.5 and we end up with a negative 16. Well, notice, I mean, let's be honest. We're dropping an acorn. It can only go to 0, right? So like after this point, we're mute at that point. What that does help us with is we're crossing our x-axis at a non-whole number x value. So that's part of it. Okay, so I'm counting these by half. So this is 0.5, 1, 1.5, 2, 2.5, 3, etc. And then we're going to count these by 5. So every 2 will be 10. And 20, so this would be 30. Okay, so at 0, we're at 20, right? It starts from a height of 20. Half a second in, it is at 16. So there's 15, so 16 would be right about there, right? 1 second in, we're at 4. So there's 5, so 4 is right here. And then 1.5 seconds in, we are clear down at 16, which is somewhere down here. So when I draw my arc, right, the best that I can, that's my parabola. And it asks, at what time does the acorn hit the ground? Well, the ground is 0. 0 is the ground. At least when it comes to the x-axis.